Hey kids, this is video 2 of thermochemical equations, and this time we're now going to add some math into the mix. And if you read the statement, chemistry problems involving enthalpy look very similar to our dimensional analysis questions. And we've done that. We did that in the unit of the atom, and we did that in unit with bonding. And something new is this idea of moles, and we've talked about moles. 1 mole equals 6.02 times 10 to the 23rd. Particles, we've talked about 1 mole equaling the molar mass in grams, but what we haven't, or what is new in this unit, is this idea of a mole in a reaction. And when we balance reactions, we call this a coefficient. But this coefficient is actually representing how many moles of, in this case, hydrogen peroxide equals how many moles of water and how many moles of oxygen. And we're going to use that to help us solve our problem. So our example problem here today is how much heat. Now, heat unit is going to be in kilojoules. So basically it's saying is how much kilojoules will be released. Released being our key word. Release tells us it's exothermic. So again, how much kilojoules will be released if 1 gram of hydrogen peroxide, and I gave you the formula for hydrogen peroxide, decompose. And you'll notice that this is in fact a decomposition reaction. So I started with my number from the problem, my given, as we've always started our dimensional analysis problems, 1 gram of hydrogen peroxide. And anytime we have grams, this isn't new, we use molar mass. So I calculate the molar mass from the atomic masses on the periodic table. Remember, hydrogen is 1.01, and there's 2 of them. And then I'm going to add oxygen, which is 16, and you'll notice there are 2 of them. And if you add that together, that will give you the 34.02. The other side of grams is 1 mole. And then now I have 1 mole. Now grams cancel. Don't forget that's the whole point behind dimensional analysis. We cancel out our units. And now we have 1 mole. This is the new part. I don't want moles anymore. I want kilojoules. So I'm going to look at my reaction here, and I'm going to find hydrogen peroxide. And here it is. And now the number in front, that 2, you'll notice this 2. They are the same. So that 2 and this 2 mean the same thing. So I have 2 hydrogen peroxides. Thus I have 2 moles of hydrogen peroxide. And then this 190 kilojoules came from the reaction, 190. And then you might be asking, where did that negative sign come from? Remember, we said it was exothermic, and in video 1 we said that exothermic was a negative. Not that it's less than 0, but we're showing that it's leaving the system. And then you're going to solve the problem exactly as you have in the past. You're going to multiply your numerators, you'll multiply your denominators, and you'll get your answer. And you will also notice that our denominator has 2 numbers, and our numerator has 2 numbers. So those parentheses in your calculator are going to become very important. So in your calculator, you should have 1 times 190, and you can put the negative sign in, divided by 0.02 times 2. Okay, notice my parentheses. I have a parentheses around the whole denominator, and I have a parenthesis around the whole numerator. And then when you put it in, you'll get this value. And then, of course, your best friend, sig figs. So 1.0 had 2 sig figs. I have 4 sig figs. I have 2 sig figs and 190. So my answer is going to have 2 sig figs. So you'll notice that we have another question here, and we're going to start that in video 3.